Here we go. We're live. We're going to talk about the distributive property today. We're going to learn. You should already kind of know, but we're going to do a little bit of a refresher. So if we were going to solve this equation right here, or this expression, using PEMDAS, using our order of operations, what would we do first? Parentheses. So what's 3 plus 2? 5, and then we take 5 times 5, and what would that give us? 25 would be what we get on that one. So that's using order of operations. Now we're going to try it this way. All right, we just distributed the 5, so now what's 5 times 3?
15.
And what's 5 times 2?
10.
We're adding those up. What's 15 plus 10?
25.
Same thing, right? Both equal 25. All right, what do we...
Then where does the 3 plus the 5 go? Oh, wait, never mind. They added and minus.
You see it? All right. So they both equal 25 is the first thing we notice.
Can you zoom in?
Yep.
What?
That's what she put? Whew.
Is that good or bad? That's both.
Yep, both
So they're both
equal 25. Right? We notice that? This one equals 25, this one equals 25?
Uh-huh.
All right, what else do we notice?
That both the equations have 3 and 2 in it.
And 5, right?
Yeah.
They both use 5, 3, and 2 in those equations. You in a good mood today or what, Landon?
Huh?
You just cheesing?
What?
Mask, please.
Oh, wait,
Where
what?
you're just chilling back there, vibing?
I don't know. I just listened to the music.
Puts you in a good mood?
I don't know.
All right.
It's a pretty good song if you listen to it. I
All right.
like it.
So this next blank says the distributive property. What goes there, Landon? What did I just say?
Distribute and property.
The distributive property
Got it.
states that we can use the coefficient outside the parentheses and multiply that coefficient with all the numbers of variables within the parentheses. It's a little confusing, but basically what we just did, do you guys all have that down?
Yeah, sort of.
What we just did is we took this number out front, the coefficient out front, and multiplied it by everything in the parentheses. So we took 5 times 3, and we took 5 times 2, and we added those. That's where we get this from. Here we have 5 times 3 plus 5 times 2. So that's our distributive property. All right, so now here's an example. What are we going to do with this 2? This is our coefficient, this 2. And we said we use the coefficient outside and multiply it with all the numbers inside. So we take this 2 times x, we take this 2 times 3, we distribute it. So now our new expression looks like 2 times x plus 2 times 3. Okay with that? Distributing there?
Yeah. Hold on. Well, where does what? How do you add that together then? So,
All right, well, let's multiply first. What's 2 times x?
what?
4.
It's just 2x. All right? We just have 2 x's now. What's 2 times 3?
6.
6. Can we combine those?
Yes.
No.
2x plus x.
Those aren't like terms, right?
That's just our answer.
That's just our answer right there. That's all we have to do. All right? Now this next one, we're going to use algebra tiles to represent, but first we got to distribute.
We're not in algebra. We're
All right.
not that smart.
If we distribute this, we're going to take 3 times x and 3 times 1. All right, so what's our new expression going to look like?
That's the answer.
Yep.
It's 3x plus 4.
3x plus 3. 3 times 1 is 3. So we'll have 3x plus 3, right? We take 3 times x, we get 3x. We take 3 times 1 and get 3. We okay with that?
Hang on.
Huh?
So we take this coefficient here multiplied by every term inside. Multiply. All right, so what would our algebra tiles look like for this one? How many rectangles am I going to have? You guys remember?
3.
3. And what kind are they going to be? Not shaded, right? Shaded is negative. So we have 3 open ones.
Why are we going back to rectangles again?
Because why not, Landon?
And we're adding what? How many squares and what kind of squares?
I'm not complaining.
Open 3.
3 open squares. Oh, that's coming dangerously close to complaining. All right, so now on this last one, we're going to use algebra tiles again, and we're going to distribute. So we distribute the 2 to the x and the 2 to the 2.
So it would be 2x and then the minus symbol and the 2.
What's 2 times 2 though, right? Because we're going to have 2 times x minus symbol,
So it's 2x
2
minus
times
4.
2. So we have 2x minus 4 would be right. All right, now for algebra tiles, how many rectangles and what kind of rectangles?
2 rectangles and they're open.
2 rectangles and they're open. Now how many squares and what kind of squares?
4 squares and shaded.
We plus 4 squares and they're shaded. Good. All right, starting to feel a little more comfortable with that? There is a backside.
Oh.
All right, one more.
It's snowing.
We're doing algebra tiles again. All right, so now we're distributing a negative 2. All right, so we're going to take negative 2 times x and negative 2 times 3. So we have negative 2 times x plus negative 2 times 3. What am I going to get negative 2 times x, Caleb? Negative 2 what? Negative 2x. So we have negative 2x plus, what's negative 2 times 3?
It's just 2x plus 3. Or 5.
Negative 6. Negative 2 times 3 is negative 6. All right, so now for our tiles, what kind of rectangles for negative 2x?
Shaded.
And how many?
3. I mean 2.
2. So we have 2 shaded rectangles.
Oh, I thought it was square.
All right, now we have negative 6. So how many squares and what kind?
Shaded.
And how many?
6.
6. All right. So now we kind of have a word problem almost. It's just going to tell us the distributive property just with numbers or with sentences now. So here we have a number plus 2. So how are we going to show a number? If it just says a number, how are we going to show that? X or n, that would work, just a variable. And then we just plus 2. How do we show plus 2? Plus 2. All right. What about 3 times a number? How are we going to show that?
X times 3.
3 times x, x times 3. Or we could just say 3x. But this is fine too. All right, either one of those are okay.
3x then plus 2 next.
So
Yeah.
3 times a number plus 2. What's 3 times a number?
3 times x plus 2.
Plus 2. That works
That's
there.
what I said.
Or again, we can do 3x
It's right there.
plus 2. Easy, Landon. Hot chocolate on the line. Careful. All right. Now this one might be a little tricky. It's 3 times the sum of a number and 2.
Oh, I know it.
You know what?
3x times 2?
Not
What's the
quite.
sum?
You know what a sum is.
No, I don't.
I don't either. I don't know either.
What's the sum, guys? What's the sum?
The answer.
Like the answer.
To what kind of problem?
The
I don't know.
Addition. When you add numbers. All right. What comes first here?
3 times x.
The sum of a number and 2 is going to come first, right? Because it says 3 times this part. So this is what we're going to do first. How are we going to show that we do that first? Using our order of operations. If we want to show that we're going to add 2 numbers before we multiply by 3,
So then you, wouldn't you put
Plus
a plus
something.
in the, like,
All right, let's look at, here's our order of operations right here. What comes first? Parentheses. And that's how we can show order, right? So we're right here. So if we want to show the sum of a number and 2, we already said a number plus 2 is x plus 2, right? And if we want to show this comes first, we just put it in parentheses. Right? Because that's what comes first in our order of operations.
That was pretty hard, actually.
But now we got to take that times 3.
Oh, you put the 3 on the outside.
There we go.
There.
So then we do x plus 2 first in our parentheses, then times that by 3.
So it'd be just
2x times 3.
yeah.
So if we distribute this, it would be 3x plus 6, right?
I was so close. I have a 3x point, but not the time. I had times.
All right. This last part now gives us the algebra tiles, and we have to write the expression that they're modeling. So Caleb, what's this first one going to look like?
2 times 3, 4.
All right, well, we're plussing. And we have 2 rectangles. What do our rectangles represent?
Oh, I know what it is. It's 2x.
Whole numbers. Landon, I didn't ask you. All right. These represent our variables, right, Caleb? So what would go in this first number then? How would our expression start if there's 2 open rectangles?
Minus 2.
If they're open?
2 no.
And then what do we got to put on the back of that? X. All right, now we said we're adding, and we have 4 shaded squares, so what comes next?
Negative 4.
-4. All right, that's our expression on that one. Now we have 4 shaded rectangles.
Negative 4x plus 4.
-4x plus 4 on that one because we have 4 open squares.
Is that homework time now?
That's almost complete.
It's
Huh?
just me though that can't complain. Everyone else can complain, so I guarantee everyone's gonna complain when I start complaining.
All right, we okay with that? All right.